So this is Geometry, Chapter 2, Section 2, called Conditional Statements. Make sure you write your name, your first and last, please, the date, the class, and the fact that this is, what surprise notes. Go ahead and write the learning objective on your paper as well, right underneath your title. So in this section, we're going to learn to recognize conditional statements and their parts, and then to write converse, inverse, and contrapositives of conditionals. You can describe some mathematical relationships using a variety of if-then statements. Alright, so our key concepts are conditional statements. A conditional statement is an if-then statement. Learning objective is to recognize conditional statements. So if you see if and then in a statement, it's fairly reasonable you can call it a conditional statement. So if P, then Q, or P implies Q. The hypothesis is the first part of the statement. The conclusion is the second part of the statement. So you got a hypothesis, it comes after if and before then. And then the conclusion, which comes at the end. So conditional statement has a hypothesis, it has a conclusion, it has if, and it has then. So let's look at some examples of that. All right, so for example, if P is equal to tears and Q is equal to sadness, let's think of two different ways we can write P implies Q. How about, we can't write if tears then sadness, because that's not a statement using, so let's write that together. So if someone has tears in their eyes, then they are feeling sadness. How about, no. Okay. If she is crying tears, then she is sad. Then she has sadness in her heart. She is in a dark place. Okay, so that's how tears implies sadness. If tears, then sadness. Alrighty, let's look at problem number 1. I got one less problem without you. So, what are the hypothesis and conclusion of the conditional statement? If an animal is a robin, then the animal is a bird. The hypothesis, an animal is a robin. Let's get a pen. An animal and a robin is the hypothesis, and the animal is a bird is the conclusion. So let's look at this. Got it. What are the hypothesis and conclusion of the conditional state? Conclusion of the conditional. If an angle measures 130 degrees, then the angle is obtuse. The hypothesis is the part following if, So you want to look for the word if, and everything after if is the hypothesis. And then the conclusion is the part following then. So we are going to circle the hypothesis and underline the conclusion. Circle the hypothesis and underline the conclusion. So underline the conclusion, circle the hypothesis. So an angle measures 130 degrees is the hypothesis, and the angle is obtuse is the conclusion. Writing a conditional statement. How can you write the following statement as a conditional? Vertical angles share a vertex. I'm going to draw a picture just so you can see. 1 and 2 are vertical angles. Identify the hypothesis in the conclusion. So if we say vertical angles is the hypothesis and share a vertex is the conclusion, we're going to write a conditional. If 2 angles are vertical, then they share a vertex. All right. So we're going to go, how can you write dolphins are mammals as a conditional? Which one is the correct statement? All dolphins are mammals or all mammals are dolphins?
All dolphins are mammals.
All dolphins are mammals. So make sure you circle that on your paper. So let's make that an if-then statement. If an animal is a dolphin, then the animal is a mammal. All right, so please write this definition on your paper. The truth value of a conditional statement is either true or false. So when we talk about truth values, there's only 2 options for a truth value. The truth value can either be true or it can be false. All right, let's read through problem number 3 together. Finding the truth value of a conditional. Is the conditional true or false? If it is false, find a counterexample. If a woman is Hungarian, then she is European. The conditional is true, so the truth value is true. Hungary is a European nation, so Hungarians are Europeans. Look at the second, B. If a number is divisible by 3, then it is odd. The conditional is false, so the truth value is false. The number 12 is divisible by 3, but it is not odd, so there's a counterexample. All right, so let's do this got it together. So if a month has 28 days, then it is February. So cross out all the months that have at least 28 days. So January has 31, so cross out January. February, nope, we keep that on the board. March, cross out the months that have at least 23 days. January, February, March has 30. April has 31. May has 30. June has 31. No, June has 30. July has 31. August has 31. September has 30. October has 31. November has 30. And December has 31. So we should have crossed out all the months except for February. So what can we say? Adam, what do you think?
Oh, I have a question.
So for the sake of argument, we're going to ignore leap year. And we're going to say that this is true. So the conditional statement is true. All the other months have more than 28 days. And you need to have the justification. This is where you're going to lose points on your, if you just wrote true, you're going to lose points because the instructions say, if you look at your example problem, it gives an explanation. So please include the explanation in your answer always. Whether you know it in your head or not, I don't know it unless you write it down. So you're going to write true because all the other months have 30 or 31 days. All right. If two angles form a linear pair, then they are supplementary. So remember, linear pair looks like this. We have a straight line. Angle A and angle B. I will accept this if you guys decide to write that it's false because of the leap year. I'll take either. If two angles form a linear pair, it is true because to be a linear pair, you must add up to 180 degrees. Okay, so the negation of a statement P is the opposite of the statement. The symbol tilde P stands for opposite. So for example, if I say P is being a student, so if you are a student, the opposite of that is if you are not a student. So a lot of times to represent it in English, we will use the word not. So you can either be something or you are not that thing. That's the opposite of being. All right, so the conditional statement uses the given, hypothesis, and conclusion. For example, if the measure of angle A is 15, then angle A is acute. So that is P implies Q, if P then Q. Converse of that, so the converse is when we flip it. So let's do a little sign with arrows to show that we're flipping it. So exchange the hypothesis and the conclusion. If angle A is acute, so instead of saying this one first, you say the blue first. If angle A is acute, then the measure of angle A equals 115. So if Q, then P. The inverse is when you negate both the hypothesis and the conclusion. So we're gonna call this the not. The measure of angle, so you keep the same order, but you just go not. So if the measure of angle A is not equal to 15, then angle A is not acute. So this looks like tilde P, not P, then not Q. And the contrapositive combines these two things together. And it's, so it switches them, and it puts the not on there. How do you like that? Not switch. So you negate both the hypothesis and the conclusion on the converse. So if angle A is not acute, then a measure of angle A is not 15. So if not Q, then not P. So it's tilde Q implies tilde P. All right, so let's take a look at some Real examples. There was a little piece of information. Below are the truth values of the related statements above. Equivalent statements have the same truth values. No. All right, so we're going to take a look at a statement, and we're going to figure out the converse, inverse, and contrapositives, and then find the truth values. If it's a false statement, we have to give a counterexample. So here's the statement. If the figure is a square, then the figure is a quadrilateral. So the hypothesis, the p-value is the figure is a square. The q is the figure is a quadrilateral. The converse is these two flipped. So if the figure is a quadrilateral, then the figure is a square. The converse is false. Quadrilateral is a shape with 4 sides, and square is a shape with 4 sides that are all the same length. A rectangle that is not a square is a counterexample. The inverse of that is when we use the same order, but we just put not. The figure is not a square if the figure is not a quadrilateral. So the inverse is if the figure is not a square, then the figure is not a quadrilateral. The inverse is false because check out these examples. This is not a square, but it is a quadrilateral for sure. So use this trapezoid, the parallelogram, and the rectangle. All right, the contrapositive is if the figure is not a quadrilateral, then the figure is not a square. Absolutely true. If it doesn't have 4 sides, there's no way it can be a square. Okay, so let's take a look at what we got here. If a vegetable is a carrot, then it contains beta-carotene. The converse is, so the converse is just going to switch these. So this is the hypothesis or the p-value. And then this is the conclusion. So I'm going to say if it contains beta-carotene, then it is a carrot. I can give you, I'm going to say that this is false. Because there are vitamins that have beta-carotene. All right. The inverse is a statement just with not. If a vegetable is not a carrot, then it does not contain beta-carotene. All right, so there is another vegetable out there that has beta-carotene, so this is false because kale has beta-carotene. That's a nice green leafy vegetable. Okay, last one. Our contrapositive. So we're going to switch them and negate them. So if it does not contain beta-carotene, then it is not A carrot. And by the way, I left out vegetable because I'm trying to burn.
It's not a carrot.
If it does not contain beta carotene, then the vegetable is not a carrot. That is definitely true because carrots.
The inverse is true. Are all of them true?
No, converse is false, inverse is false, contrapositive is true.
Converse is false?
Mm-hmm.
Oh. Oh.
Because I can take a beta carotene supplement, and that's not a carrot. And it has beta carotene in it.